In this lesson, I'll show you two examples on how to find the frequency of a waveform. The first question reads, find the period and frequency of the function y is equal to sine 6x, both in degrees and in radians. Now what's interesting about the frequency is that it is the reciprocal of the period. And that's represented right here, where frequency is equal to p superscript -1, which suggests the reciprocal of the period. And if that's the case, if frequency is equal to b over 360 degrees or 2 pi, then the period, if we're finding it in degrees, will be 360 over b. And of course, this can be either degrees or 2 pi radians. Now, how do we identify b in this equation? We have sine 6x. The general equation of a sinusoidal sine function looks like this. Y is equal to a sine bracket bx plus c plus d. So if we mix and match this general pattern with the equation that they give us, b is equal to 6. So I'm going to find the period by substituting 6 into here. 360 degrees divided by 6 gives us 60 degrees per every cycle. So b represents the cycle, and to find the period of each cycle, you divide by 360. Of course, if we want to find the frequency, we'll take the reciprocal of the following, and we end up with 1 over 60 degrees, or 1 cycle per every 60 degrees. That's the answer in degrees, now in radians. So the period is equal to 2 pi radians this time per every 6 cycles. Dividing this, we should end up with 1 over 3 pi radians per cycle. The frequency will be the opposite, 3 over pi cycle per radian. Let's move on to question 2. In question 2, they want us to find the period and frequency, but this time our function is different. Y is equal to 4 cosine 4 theta minus 2 pi over 3. Then they want this both in degrees and in radians. Let's start with degrees. To find the period, we say period is equal to 360 divided by 4. That's your b value, your cycle. 360 divided by 4 is equal to 90 degrees per cycle. The frequency will be the opposite. It will be 1 cycle per every 90 degrees. This represents the frequency. In radians, we have 2 pi radians over 4 cycles, and that reduces down to pi over 2 radians per every 1 cycle, and the frequency will be the reciprocated version, 2 over pi cycles per radian. And there you have it. That is how to find the frequency of a waveform.